Hello students, this is one of our last lectures in which we're actually talking about bone growth, and we'll also get a little bit into bone remodeling in this lecture as well. In this case, we're looking at bone growth. We're looking at it postnatally. We're looking at bone growth after birth. And as I said in the last lecture when we talked about bone growth after birth, it occurs at what is called the epiphyseal plate. And these are this is a small line of cartilage that is in the epiphysis at the ends of the bones, and we'll still follow the same basic model that at this epiphyseal plate new cartilage will be formed, and then that cartilage will be calcified. It will be turned into bone matrix, and this is how we will get to bone growth throughout childhood into adulthood. It's similar in the way it works into way if you'll remember back to when we had skin regeneration and we had several different layers of the epidermis, and there was one layer that was continually producing new skin cells, and then those new skin cells would be pushed, and as they would be pushed and migrated, they would differentiate and change. And the same thing is going on at the epiphyseal plate with the growth of bones in children and adolescents. So again, here, looking up here, here's a long bone, here's the epiphysis of the long bone, and here's the epiphyseal plate. And this is where bone growth will occur throughout childhood. If we take that, we're going to blow that up. We'll see that once again we have these different layers, and let's work through these layers. This would be, if we take this, we're going to blow this up. So here would be kind of towards the end of the bone. Here would be more towards the middle of the bone. And so our first layer, we have what's called this proliferation zone, and here we have cartilage cells, and the cartilage cells are growing and dividing. They're replicating, they're undergoing mitosis, they're growing and dividing and forming new cartilage cells. As the new cartilage cells form, the new cartilage cells will push the more recently formed cartilage cells into this hypertrophic zone, and here these cartilage cells, now they're a little bit older, they'll start to enlarge, and then those cells, they'll migrate, they'll be pushed into this calcification zone. At this point, this is where those new cartilage cells, those cartilage cells begin to die, and there are osteoblasts in that zone that are then creating and depositing the new bone matrix, so that finally here in zone 4, the ossification zone, here is where the cartilage tissue has been completely reformed and replaced by the bone matrix. Now, this one last slide I want to get into. This is initial discussion a little bit about bone growth versus bone remodeling. Up through childhood, through adolescence, and early adulthood, we have this bone growth. And remember, in bone growth, here's the epiphyseal plate, and the cartilage is growing here. And then as that cartilage grows and forms new cartilage, then that cartilage will be replaced by bone tissue on the inside of that epiphyseal plate. In bone growth, the same thing is happening at the very ends of the bone in the articular cartilage. The articular cartilage can grow and form new cartilage, and then that cartilage is replaced by bone tissue. And you can see that I will slowly get a lengthening of bones as I do that. Now, in adults, we're no longer getting bone growth, but we constantly have this process of bone remodeling going on. As I said earlier in an earlier lecture, per week, about 7% of our bone mass is replaced by new bone tissue. And here in the bone remodeling, what will happen is that in certain areas, the bone will be resorbed. The bone will be broken down by osteoclast. And then in other places along the edges, along the membrane, bone will be added. Bone will be added by the osteoblast. So in bone remodeling, we have this thing going on between osteoclasts that are producing new bone and osteoclasts that are breaking down bone. And as we'll see in an upcoming lecture, that is under the control of certain hormones. Thank you.